Amazing places, gonna meet cool people, some of them really cool. And together, we're gonna learn a thing or two. So come on, let's go.
Earth. It is so vast and so beautiful. It can be hard to grasp that we could possibly ever alter it. Maybe that's because the largest force that's changing our climate is invisible. My name is David Schechter, and I'm your guide on a journey to explore how we're changing the Earth and how the Earth is changing us. This is On the Dot.
We're going to the Mauna Loa Observatory, and this is where the carbon dioxide readings come from. And I'm like, I gotta go see that place.
When it comes to office views,
Thanks for having us out, man.
Yeah, of course.
Aiden Colton is crushing it. We visited him before a recent volcanic eruption temporarily interrupted operations up here.
It's not the easiest place to get to, as you can see.
No, it wasn't that easy.
It's not the easiest place to work. It's 11,000 foot elevation. You know, every time you take a breath of air, you're breathing in a third less oxygen.
Too much carbon dioxide in the atmosphere is what drives climate change. And for the last 65 years, scientists around the world have relied on the carbon dioxide measurements taken on Mauna Loa. Aiden is the guy who takes them, and he invited us to come along.
This is the carbon cycle NOAA portable sampling unit. And what we're doing here...
Kind of looks like the nuclear launch codes might also be in there.
Yeah. Luckily, they're not.
Aiden's telling me the air up here is what makes this remote location so important. We're more than 11,000 feet up, far above any ground level pollution from communities below, and we're surrounded by 2,000 miles of ocean. So by the time air makes its way here, it's been blended with air from across the globe.
All right, so we'll just hold our breath, just because that's what I usually do when we get like 10 seconds. But once I close it off,
We have to hold our breath.
it's very hard to affect it, but we don't want to contaminate.
Tell me when I have to hold my
right,
breath.
I looked over at you and I'm like, I don't think you're gonna be able to do this.
Chance. Hold your breath.
I couldn't hold it. I had to breathe.
These samples, gathered once a week, will be sent to a lab for analysis. There's also a tower, another 140 feet up, that pulls and analyzes samples 24 hours a day, determining how much carbon dioxide is in the air at such a high altitude.
You have all this research from this location. What story does it tell?
Our job is to present the facts. And the fact is that carbon dioxide is increasing, and it has been increasing since we started monitoring it.
Starting in 1958, this graph of samples taken in Hawaii shows the concentration of carbon dioxide in the atmosphere rising year after year after year. Now let's go back in time by 800,000 years. By studying things like ice core samples, ocean sediment, and tree rings, scientists have a good idea how much carbon has historically been in the Earth's atmosphere. It goes up and down over time, but it's never crossed this line. And now, let's bring things back to what's happened in the last 65 years.
The CO2 in the atmosphere has never been seen this high in human history. It's harder and harder for me to speak to people like yourself and be optimistic. I want to see some change, and I want to see it start to plateau.
So we've got a lot of carbon dioxide. Now let's talk about where it's coming from.
So I think this next stop would be pretty cool. This company has figured out how to visualize carbon dioxide.
Hello.
Davida Herzl is the CEO of Acclima. In Oakland, her company operates a fleet of cars outfitted with tubes and sensors that analyze the air for 14 kinds of pollution. One of them is carbon dioxide, which floats straight up into the atmosphere and can stay there for hundreds of years.
To deal with climate change, to deal with air pollution, you really have to understand where it's coming from, and you have to take local measurements to do that.
So as we're driving, how many measurements are happening right now?
Right now, every single second, we're taking a measurement.
Off this hose?
Off of that, yeah, the air is getting sampled, we're moving through the streets, that enables us to pinpoint the precise location of those measurements.
There are a lot of ways that carbon dioxide gets into the air, but according to the EPA, the #1 source of carbon emissions is transportation at 27%.
You can look out the window. I can count 1, 2, 3, 4, 5, 6, 7, 10 trucks just in front of us right now.
Diesel trucks.
Diesel trucks. And what you're looking at here, that's the CO2 coming off of these trucks.
What she's showing me is a visualization of carbon dioxide on the streets of Oakland. The lower concentrations are purple on the side streets. The much higher yellow levels are freeways. And those things that look like skyscrapers are emissions where two highways come together. Businesses and governments use Acclima's data to identify and reduce sources of pollution.
This isn't just an invisible problem. You can now see it. It's visible. It's measurable.
And when I drive,
And when you drive,
contribute.
you're contributing. You're putting CO2 into the air.
So the level of carbon dioxide in the atmosphere has exploded, and transportation is a major contributor. But why is carbon dioxide a problem?
We're trying to get an idea of how this greenhouse effect works. How does CO2 have this power over controlling the Earth's temperature?
Dr. Eugene Cordero is a climatologist at San Jose State. We're meeting up at a science museum in Oakland, and he's going to help us understand the greenhouse effect, where carbon dioxide functions like a blanket around the Earth. He's telling me as the Earth naturally radiates heat, the carbon dioxide in the atmosphere retains some of that heat, and that's what makes the planet comfortable. His demonstration here involves a candle, a camera, and a piece of glass.
so you were kind enough to bring a candle. I also stopped and got a few candles.
Oh, cool.
Fresh lavender breeze.
Oh, that's
That one
nice.
smells pretty good.
Yeah, so we're going to have a heat source. This like represents the Earth. So the Earth gets warmed during the day by the sun, and then it gives off energy. So we have
This is
our
the heat
energy
of the
source.
Earth?
Yeah, right there.
Okay,
So we have our planet right there.
okay.
And then we have this camera, this special camera that senses infrared radiation or heat. And that's like a satellite orbiting the planet. To be honest, that's the best way to measure this greenhouse effect.
From
is
space.
From space.
Is this our carbon dioxide?
Yeah, it behaves in the same way because it absorbs this particular type of radiation.
So I'm going to basically put the carbon dioxide
You're going to put this blanket of carbon dioxide
in between the Earth and the
in the
satellite in
satellite.
space.
Yeah.
It just disappears.
Take a closer look at the candle. The wavelengths of heat show up as white, red, and yellow. When the glass comes into frame, it shows up as solidly purple, so you can't even see the candle behind it. Dr. Cordero is saying when you add more carbon dioxide to the blanket around the Earth, our planet retains more heat.
Our natural light from the sun passes through, but then the infrared radiation on its way out
Can't get out.
can't get out. But now we have a lot more CO2 than we used to, and so our planet's temperature is going to go up. It's a great thermostat.
Now let's take another look at that graph from Hawaii. This is the line that shows carbon in the atmosphere going up and up. Now add in global average temperatures. As the carbon dioxide rises, the temperature rises too. Dr. Cordero says a large body of research shows us that is what's driving extreme events like fires, floods, and drought.
How long have we known that carbon dioxide can do something like this?
Yeah, over 100 years.
Over 100 years.
Yeah, so that the CO2 and other greenhouse gases is the largest contribution to changing what our planet's like right now and making it warmer. There's other factors too, but carbon dioxide is the #1.
How worried should I be about that piece of glass?
I think this is our main social environmental challenge for humanity.
When it comes to climate change, carbon dioxide is an invisible problem. But we've seen, with a little imagination, it's not impossible to understand what it's doing up there, where it comes from, and how we have more and more in the atmosphere every year. Together, we're going to explore how changing the climate changes our world and what we can do about it.
So I learned something pretty cool. When snow falls, it retains the temperature from the day it fell, and those layers of snow can tell us a lot about how winter is changing. That's coming up next.
can't believe I'm doing this.
These people go in the lake every day and stay there for like sometimes 10 or 20 or 30 minutes. This is not something that normal people should be doing.
These folks have found a way to embrace the extremes of winter. And this morning, I'm not the only first-timer out here.
Ever thought you'd swim in hat and mittens?
So is Dr. Heidi Roop, a climatologist at the University of Minnesota.
You can do anything for 30 seconds, right?
Yeah, girl.
Oh my God.
Yeah. Deep breaths, deep breaths.
Are you guys nuts? Holy. Oh.
It might not always feel like it, especially when you're chest deep in a frozen lake, but winter is getting warmer.
Yeah.
Heidi, how you doing?
Great.
How are your toes?
My toes. Do I have toes?
My name is David Schechter, and this is On the Dot, a journey to understand how we're changing the Earth and how the Earth is changing us. That guy in the zebra jacket, that's Dr. Andrew Schwartz.
Man, you know how to make an entrance.
How's it going?
That's awesome.
He's an atmospheric scientist with the University of California, Berkeley, and he runs the Central Sierra Snow Lab.
7 feet roughly, 190 centimeters.
So evidently we were digging a pit of snow, and then we're gonna go in the pit and we're gonna talk about the snow. Do I have that right?
You do have that right.
Okay.
Together, we're digging a snow pit so he can look back at this season's snowstorms.
This is actually, I'm pretty sure where they're gonna bury me when it's all done.
Digging your own grave, man.
Yeah.
Snow is obviously critical to outdoor recreation, but there's an even bigger concern here. So let's talk about snowpack. That's water stored as snow in the mountains. Traditionally, it melts in spring and summer, and that's how California gets 30% of its water. If the snowpack melts too early, you can get floods, and by summer, there's not enough water when water is crucial.
What are you doing right now?
So the purpose of this whole pit is to give us a story about the snowpack. It has the different layers from different storms. We can see a little bit of ice there. 125, ooh, she's a warm one. So we get measurements of the temperature of the snowpack to figure out, is it ripe for melt? Is it still pretty cold?
These layers of snow can have different temperatures depending on how warm it was the day it fell. The higher the temperature in the snow, the faster it will melt, a major concern in the era of climate change.
Once that goes above freezing, that's when we can no longer have the snowpack, and this is all going to disappear and switch to
What's
rain.
that temperature doing over time?
It's climbing. We expect a transition away from snowpack and to rain within the next several decades.
He knows that because the Snow Lab maintains the oldest continuous winter weather records in the country. For the month of January, for example, the minimum daily temperature at the lab goes up and down over the years, but the 50-year temperature trend is rising relentlessly towards 32 degrees, the line between rain and snow.
What does the warming winter mean to the snowpack?
The snowpack is less reliable and more variable than it used to be. And if we're switching back and forth between, snowfall and super warm days and snowfall and super warm days, we might not have the chance to really build an efficient snowpack to run off to the agriculture and farmers that need it.
3, 2, 1, go!
There's nothing like an early morning ski race in Minnesota. This is a community that puts on big events to embrace winter culture.
The strength of our collective and individual action.
And they're striking up public conversations about how to lead on climate change. Like much of the country, Minnesota has had a weird winter. There's been a ton of snow.
Who wants it? Who wants it?
But when it comes to skating, some lakes took 6 weeks longer than normal to freeze.
That's a goal.
Scientists are reluctant to blame any one event on climate change, but Dr. Roop is saying they do see the larger pattern.
We're confident saying that what we are experiencing as a whole in aggregate is what we expect from climate change, and that volatility, that sort of unpredictability, that weirdness, if you will, is climate change.
Nationally, since 1970, winter has warmed in the Pacific Northwest by 1 degree. From Southern California through the middle of the country, it's around 2 degrees warmer. But parts of the Midwest and East Coast have warmed up to 5 degrees, with extreme warming in parts of New York, Vermont, and northern Minnesota of about 7 degrees.
We see, again, these patterns of concerning warming, and that is changing what winter looks like, what it feels like, and that has then, again, implications for what we experience.
Concern about climate change led Minnesota to pass a new law. It requires all electricity come from renewable sources by 2040.
Can this community actually be part of preserving winter? It seems like a pretty big, daunting challenge for one community to do.
We as one community are not going to be able to change the trajectory of global average temperature. So if all communities or many communities come together and catalyze change, then the answer is yes.
So the change in winter doesn't just affect communities where it's always cold or always snowy. Lots of places are dealing with these changes.
I'm Paul. David. Nice to meet you.
So I'm drinking wine during the day, like you do, with Paul Bush. His family has owned the Madroña Vineyards in Camino, California for over 50 years.
And if I were really nice to you, we would be having some blue cheese here and everything.
Why aren't you being nice to me?
Paul's telling me consistently chilly winter temperatures are critical to maintaining healthy grapevines.
They need to go dormant. They need to lose all their leaves and basically store up energy to push buds for the next year. The earlier you bud, the greater chance you're going to have a problem.
And last year, Paul had a problem he'd never seen before. In February, it got unseasonably warm. As a result, the vines started to bud. Then came a frost that killed the buds. In March, it got warm again, more buds, another frost, and in April, it happened for a third time.
Our harvest on the vineyards here, we lost about 70%. That's hard on a small family business.
In addition to grapes, fruit crops across the country like apples, blueberries, and peaches also rely on chilly winters. That didn't happen in 2017 in Georgia and South Carolina, where fruit farmers sustained $1.2 billion in crop losses.
There's the bud.
Okay.
That's next year's crop right there. And so this one will come out here.
Take that out close to the trunk.
To adapt to the wild swings in winter weather, Paul is experimenting with a new technique, delaying when he prunes certain varieties.
Pruning it later, it delays the bud break.
So you're protecting yourself against losing those really precious buds.
Yep, but I think that's where all vineyards, all farmers are learning to adapt to what we can do. And there are certain things we can do and certain things we can't.
I mean, you got to embrace the season around you, right?
You don't have to love winter to understand it's something to be celebrated and protected. But that doesn't mean I'm staying in this frozen lake 1 minute longer.
Are you supposed to be able to feel your legs?
No.
Okay, because I don't feel my legs.
So refreshing.
You know what? I feel pretty great right now.
Coming up next, sea level rise is a problem that feels way off in the future. But we found several communities who are right now preparing for the worst. Over time, the trend is just undeniable. The measurements are all saying the same thing. Glaciers are melting, and the ice sheets, Antarctica and Greenland in particular, are contributing. So yes, sea level's rising. It's going to continue to rise, and it is one of the most obvious signs of climate change.
Sea level rise. It happens so slowly, a tiny bit each year. It can be easy for most of us to kind of ignore it. But while the 30% of Americans who live near a coastline do not have the power to stop climate change on their own, some communities are grappling right now with how to adapt to a rising sea.
So there are a lot of big projects that are happening here in New York, and I think the best way for us to see this is to go on the water. We're on a boat.
We are on a boat. This is the best way to see New York City.
It turns out there are a lot of ways to adapt to sea level rise. To see how New York City is doing it, I'm taking a trip on the East River with Daniel Zerilli.
It's quite a deal. Yeah, it's great.
He was recently the city's chief climate policy advisor.
How does the factor of sea level rise threaten the coastline here?
Sea level rise is relentless. It's not like a storm or, you know, a acute impact. It's, you know, it's just going to keep coming.
A new government report found on the East Coast there will be 10 to 14 inches of sea level rise by 2050. In New York City, where there are 520 miles of coastline, projections of future storm surge compounded by sea level rise, shown here in blue, would impact most of New York's coastline and be particularly bad on the east side of Manhattan, where they are now building a massive seawall.
As we're going along the water here, we sure do get a sense of how huge this project is. I mean, it's long.
It's, you know, almost 2.5 miles of protection.
How significant of a construction project is this?
This is huge.
Tom Foley is the construction commissioner for New York City.
It would have been easy for us to actually just build a wall around Lower Manhattan.
But that's not what they did. The new seawall is integrated into a tiny footprint inside a crowded neighborhood. Here there are 18 floodgates that will be open all the time for people to pass through until there's an emergency. The gates slide shut and the wall is designed to keep out storm surge. 10 years ago, Superstorm Sandy slammed into New York. This neighborhood, where more than 100,000 people live, was underwater, a sign of things to come.
During Sandy, we would have had the water basically up to our waist at this area.
So in your projections, do you think it's realistic that in the next 100 years, we're going to get something that gets up to the top of these gates?
Potentially, yes. And I think that with the wave propagation, with sea level rise, with climate change, that it could happen, but we will be prepared.
The right solution for every part of the city is going to be different. In this case, Lower Manhattan, high density, there's almost no other choice.
You just have to harden your defenses against this.
That's right.
Kind of orient me, where are we?
We are at the edge of the Ormond Beach Preserve, which is about 650 acres of coastal wetlands.
As the sea is rising, what's important about these natural places?
So wetlands have a superpower. They're able to buffer against rising seas. Dunes, wetlands can absorb floodwaters and protect the communities behind.
Alyssa Mann with the Nature Conservancy is telling me much of Southern California's coast used to look like this, a system of beaches, dunes, and marshes protecting against the threats of the ocean. Today, Ormond Beach is one of the last remaining examples of that.
Just by standing here, you can automatically feel that the dunes offer protection.
Yes.
There's
all of a sudden there's no more wind.
No wind over here.
By the end of the century, future storm surge compounded by sea level rise would likely push floodwaters, shown in blue, through Ormond Beach, up into these Oxnard neighborhoods, and swamp this major naval base to the south. So what's Oxnard's plan to adapt? Well, over the years, Ormond Beach has been chopped up for farmland and industry. The plan now is to restore the size of the marsh, making it into a larger buffer space for floodwaters. That means buying up surrounding land, including the power plant, and returning it to its natural state.
When California was developing, we built right up and sometimes on top of dunes and lost that natural protection. And so part of what we're thinking about here in California is where could we make space to restore nature's protection.
And this isn't just about saving fancy beach houses. In Oxnard, expanding these natural defenses will also protect the largely working class community that lives closest to the dunes.
I think what's so powerful about nature-based solutions is that they continue to build up. They continue to provide more resilience through time.
Down the coast in San Diego, these train tracks are the only rail connection between here and Los Angeles. While the view is amazing, the cliffs are eroding. As sea levels rise, waves can push in further, pounding the base of a cliff. Here they are considering another kind of adaptation, moving out of the way. There are now serious discussions about relocating the tracks at the cost of up to $4 billion.
Well, so now you get out, you can kind of see the cliffs.
In a nutshell, right? I mean, the cliffs are vulnerable to this undercutting from the wave action.
The Scripps Institute of Oceanography in San Diego is a global leader in climate science, and they've been measuring sea level rise for more than 100 years. And that's where I'm meeting up with Dr. Mark Merrifield, an expert in climate change adaptation.
It's pretty clear that something has to be done. So this is a good time to think about a solution for the train, right? I mean, I don't think there's a whole lot of time left until that.
It's literally on the edge.
Yeah.
Witnesses say the cliff collapse came with no warning. Investigators say one woman was killed on the beach, 2 other victims were airlifted and died later at the hospital.
Scripps is trying to get ahead of the kind of cliff collapse that in 2019 killed 3 people at a popular surf beach nearby.
Trying to understand the processes that are driving the erosion and how fast they're acting on the cliffs.
Once a week, this truck with an image scanner on top maps the face of the cliffs down to the millimeter, so week by week they can detect if rocks have fallen off. They're hoping to use the data to create an early warning system for cliff collapse. But ultimately, we've got a lot more than train tracks to think about. Our coasts are lined with industry, roads, and people's homes.
What do you see here if we came back here in 100 years, what would this look like?
That's the problem with this issue, is that for you and me, in our lifetime, we won't see the kind of changes you're talking about. But for our children and our grandchildren, we're leaving them with a very, very uncertain future that will no doubt be far more challenging than what we're facing now.
Sea level rise driven by climate change is a slow motion problem that's easy to ignore. But pay attention, and it's clear. From coast to coast, we have got a lot of hard decisions to make about how we're going to adapt. Thanks for watching. We're headed back on the road now to bring you more stories. I'm David Schechter, on the dot.